You may have come across this technique before, but it's a very useful one, and we'll go through and explain it here now. It's used in trigonometry when you've got tan equals opposite over adjacent or whatever, and you're trying to solve something where the unknown's in a fraction, or you may even be using the sine rule, which we've already done, and you're trying to find the unknown there. So let's just go through and see how it works. We've got 3 on 5. Let's look at this first one. We've got 3 on 5 equals x over 2. Now we've got an unknown, and we've got a single fraction on the left and a single fraction on the right. And what you can do is, when you've got a single fraction equals a single fraction, you can put a cross through the equals, and then we multiply along the arms of the cross. It does not matter which one you do first. Now we are trying to find this x up here that'll make that true. So if we want to pick up the x, we will do that diagonal from the 5 up rather than the 3 down. So 5 times x is 5x. Bring the equals under equals, and then we do the other arm, 3 times 2. I'll just put that down, I think we all know that's 6. So we got 5x equals 3 times 2. So 5x equals 6. To get x by itself, we divide by 5, divide by 5, and that's 1. So we get 1x on 1, or x is equal to 6 over 5. And that's the only value of x that'll make that true. 3 over 5 is 6 over 5 over 2. Okay, what happens when we don't have? It's very similar to this. We've got 3 on 5 equals x on 2 plus 1. So we don't have a single fraction equals a single fraction. Can we make this right-hand side into a single fraction? Yes, we can. So we get 3 over 5 equals x on 2. Now 1 is like the number 1 on 1, and we've got to make, when we're adding fractions, we've got to make denominators the same. So that'll be 2 over 2, which is equal to 1. So we get the denominators are the same, so we make that 2, and we just put x plus 2, and that'll be 3 over 5. Okay, so now what do? We do our cross multiply. So we put a cross through there. We've got a single fraction. So once again, the unknown's up here, so I'm going to put 5. Now put a bracket when you've got more than one term there. So 5, open bracket, x plus 2 equals 6. 3 2s are 6. We move our brackets. 5x plus 5 times 2 is 10 equals 6. We've got to get the term containing the variable by itself, so we've got to get rid of this plus 10. The way to get rid of plus 10 is to take 10 from both sides. 5x equals 6 minus 10 is negative 4. So divide by 5, divide by 5. So we get x equals minus 4 over 5. Okay, now I've been sort of espousing the check business, so let's just see if we can check. So check left hand side, well, it's no evaluation, is equal to 3 over 5. The right hand side equals x on 2 plus 1. So x on 2 plus 1 equals, now x is equal to minus 4 on 5 all over 2 plus 1 equals, we are dividing by 2, so we've got negative 4 on 5 divided by 2. Now 2 is 2 on 1, so we're dividing by 2 on 1, so we change the divide to a times, and we flip 2 on 1 to 1 on 2 plus 1. Now 2 into 2 once, 2 into 4 goes 2, so we get negative 2/5 plus 1. Now 1 as a fifth is 5 over 5, that's the same as 1. Negative 2/5 plus 5 on 5. Negative 2 plus 5 is 3 on 5, which is equal to the left-hand side. So we are correct. So our answer is x equals negative 4 on 5. So that's the cross multiply. Let's do the third example here. We've got c's, the unknown, the variable, on both sides. We do have single fraction equals single fraction. So we can go straight to the cross multiply method. Okay, does it matter which one you do first? Not really, because we're going to pick up some c's each way. So let's do this one first. So 3c, 3 times c is 3c equals, it's good to put the number at the front, 8, this number, 1 minus c. Okay, remove brackets first. So we got 3c equals, this 8 is distributed over both terms, so that'll be 8 minus 8c. Okay, now which side has the most positive unknowns or c's? This has got plus 3 of them, this has got negative 8, so there are more positives over there, so this is the side that I'm going to put all the c's onto. So if I want to put the c's over here, I've got to get them from here. What's the opposite of taking 8c? Plus 8c, and if I add 8c there, I've got to add 8c there. And when we work through that, we got 3c plus 8c, which is 11c, equals minus 8c plus 8c is 0, so that's just equal to 8. And then we divide by 11, divide by 11 to get c by itself. That'll be 1c on 1, which is just c, is equal to 8 over 11. Alright, now I will leave it to you to go and do the substitution. It's to do your check, left hand side, and work through and put 8 on 11 in there, and then the right hand side, and hopefully you'll get that one equals that one like we got down here. You'll get the left hand side and the right hand side equal to the same thing. But that's the way the cross multiply method works. Just make sure that you've got single fraction and a single fraction. Here we didn't have that, so we had to make this into a single fraction, and we got there, we've got the single fraction and a single fraction on each side, and then we can do the cross multiply method.